All right, for our second triangle, if you take a look at it, you might notice that we've got a triangle, but we don't have any of the sides labeled. So we don't have that information. So if you're trying to find SOHCAHTOA, sine, cosine, tangent, you need to know all three sides of the triangle so you can put the opposite over the hypotenuse and, all of those. So what can we do with this problem? Well, the only thing they told us is that we have a 30-degree angle right here. So that doesn't seem like very much information, but it actually is enough to tell us. This is going to be, because of that 30 degrees, this is a 30, 60, 90 triangle. So from last chapter, you'll remember that's one of our special right triangles. Here's our 90 degrees, which means this must be our 60 degrees up here. All right, so we're trying to find ratios of this triangle. We don't have any of the sides, so we can fall back on how we deal with a 30, 60, 90 triangle. If you remember the side across from the 30, we always labeled with an X. Our hypotenuse was always 2x, and our third side was always x root 3. All right, so how does this help us? They all have x's in them, and we don't know what x is. So if it's a special right triangle and you're not given the sides, you can go ahead and let x equal 1. You actually could let x equal any number, but your answers, you'll be able to reduce the fractions. So to get the most reduced fractions, you can let x equal 1. So what that means is this side is a 1. The hypotenuse is 2 times 1, which is 2. I'm going to go ahead and circle. So these are our side lengths. And then our third side is 1 times the square root of 3, which is just the square root of 3. So we're going to use those 3 side lengths. All right, so now to get to sine, cosine, tangent, remember that's SOHCAHTOA. We're really liking this SOHCAHTOA stuff. And this is all, this sine, cosine, and tangent, all in reference to the 30-degree angle. So here's the 30-degree angle. So again, label your sides, go across from the 30 degrees to get the opposite side. So the opposite side is 1. The longest side is your hypotenuse, and then the other side, the side that's touching the 30 degree, is your adjacent side. All right, so sine, cosine, tangent. Sine is opposite over hypotenuse. If we're looking, the opposite side is a 1 over, and our hypotenuse is 2. So 1 over 2. All right, cosine is adjacent over hypotenuse. Our adjacent side is that square root of 3 over, our hypotenuse is 2. So that is that answer. And then the third one, tangent, is opposite over adjacent. So if you forget what they are, just remember that's why we write out SOHCAHTOA. It gives you the proper order for how to divide these ratios. All right, our opposite side is 1, and our adjacent side is the square root of 3. All right, well, something's happening with this one. If you remember from our last chapter, you cannot have a square root in the denominator of a fraction. So we have to do that fun thing where we rationalize the denominator. We multiply the top and the bottom by the square root of 3. Well, on the top, 1 times the square root of 3 is just the square root of 3. And on the bottom, the square root of 3 times the square root of 3 is 3. And there is our tangent of angle 30. All right, so sine, cosine, and tangent of angle 60. What I'm going to do for this one, I feel like I should rewrite this problem because I'm running out of room. I'm going to go ahead and redraw the triangle. And I'm just going to go over here. All right, so but then I have to remember what the triangle looks like. Okay, so our triangle, remember this is our 30 degrees and this is our 60 degrees. I'm going to still have the same lengths on each side. So remember it was a 1, a 2, and a square root of 3. But the change is going to be, we need sine, cosine, and tangents in reference to the 60 degrees. So that changes a couple of your sides. The opposite side is going to be across from the 60, so that's our square root of 3. The hypotenuse is still 2, that's never going to change in a triangle. And then the adjacent side is the 1. So we're going to find sine, cosine, tangent, so ca, toa. All right, our sine of angle 60 is equal to the opposite over the hypotenuse. And if you look, the opposite side is the square root of 3, and the hypotenuse is 2. All right, cosine of angle 60 is the adjacent side over the hypotenuse, and the adjacent side is 1, hypotenuse is 2, so there's that answer. And then the last one is tangent of 60 degrees, and tangent is the opposite over the adjacent. Our opposite side is square root of 3, our adjacent side is a 1, and that simplifies to just a square root of 3. And there's our sine, cosine, and tangent of 60 degrees.